We are going to learn about how to model spring mass damper system into Simulink model. So here is the equation for spring mass damper system. So that is mx double dot plus cx dot plus kx equal to external input force, that is Ft. F of t may be in a harmonic function or any kind of a function. So this equation is to be written in some different form so that we can go on modeling into the Simulink. So I'll write this equation and I will bring this x double dot onto one side, this x double dot. So that is f of t will come here minus cx dot minus kx, and that is divided by m. So this is to be modeled using multiple blocks into this, and when you are going to integrate this once, it will give you a velocity, and one more time if you are integrating, it will give displacement. So for this purpose we need to now create blocks into this. Means we are first of all creating a block having an output as an x double dot. Input will be three inputs. One is going to have an f of t here, then second input is cx dot, third input is kx, and here we are going to have, this is a sum you can have, and one more gain you need to add up here to accommodate 1 upon m, and then you need to have an integrator block here 1 upon s, then another 1 upon s, like this. So this is output of this. This is nothing but an x double dot. You got it here. Here as after integration you will get an x dot. After one more integration you will get an x. So obviously now you need to connect this all the blocks. So this kx is to be multiplied with a block k as a gain for it, and here it is in a x signal. So this is again multiplied with a c, and it is to be connected like this. So this f of t is maybe some step input you are going to give it, and you are going to do the simulation. This kind of a model you can create into the MATLAB. So we'll now look into the MATLAB how to do it. So first of all, start in the MATLAB, then click onto the Simulink, then start in a new model here. So in this new model, what is to be done is we need to bring all the blocks into this model window. So in this we need to search where are these integrator block, sum block, gain block. If you are going to have a continuous type of operations like a continuous integration derivative, so you can use continuous blocks. There is discontinuous blocks are also there, where it is typically jet transformed kind of activity will be done. So here we will bring one integrator here. We need two integrator. We'll bring two integrator. So in math block you can find a sum block and gain block. So we'll collect a gain block, one block here, then similarly we'll go on sum block here. So this is a sum block, and in sources we can get the step input. So here it is in a step input as in a forcing function. Then so this is what currently we are looking for it. And one more thing we need is where you want to monitor the displacement and velocity of the graph. So for that purpose we are using a scope here. So this is one scope. So here we are going to now start with a sum block. Double click onto the sum block. So it will open up in a window where you can change the shape of it to a rectangle, which will help us to look into the better fashion. That's the reason we are converting it. So here how many in sum block? There are three inputs. One is plus, second is negative, third is negative. Similar fashion, you can now give the names for it, plus, minus, minus, and then click on OK. So obviously it will convert into rectangular block. So this is 1. So you can bring block here. Here we need to give gain as in 1 upon m. Okay. So this m is nothing but a symbol. We are now later we are going to give it to value for this and afterward. So if you increase the size of this, you can look at it. So first is input is a positive, then again you need to bring one more block. You can copy down, drag and control and drag you can use. Here it is in a damping coefficient. Right click onto this damping coefficient so that you need to flip it, flip the direction of it so that it will be easy to do this. So this is x dot signal connected to this, then again double click onto this, you provide k, here connected this. Okay, this way we modeled entire model, spring mass damper model. Now this is all is doing in a entire equation of mx double dot plus cx dot plus kx. So we can right click, select this and create in a simple subsystem for this. We can create in a subsystem for this. So this is what in a simple subsystem we got it. We can give the name for it as in a spring mass damper system. We are not given any kind of values for m and c values. So we can double click onto this. You want to now give the values for m, c, k, which are it is necessary. So for this purpose, you can right click onto this. You can go into the masking of this. That is what it is called as a masking. We need to create a mask for it. So when you click onto the mask, you can assign some variables for it. So that is parameters, we can say. You can add the parameter. First parameter is in a spring constant. Here typically spring constant we are going to give in a init for it. We give the variable name as in a k, then damping coefficient. So unit is Newton second per meter. Value of this is c. Name of the variable, it is mass, is typically in kg. So we are going to give the name as in m. Then click on apply. Then OK. So once you provide a masking for it, it is automatically creates an arrow here. Double click onto this. It will ask you the values for spring mass dampers. We can give values for this. Mass is given a 1 kg somewhere. Then click on apply. Then now later is the next step is to decide the simulation parameters. In this simulation, you can now decide what type of OD solver you want to use it for simulation purpose. So here you can use an OD 2, 3, OD 4, 5 type of model, and so this will tell you the entire window. This is for 10 seconds you want to simulate. You want to go for a variable step. Here you want to go for an OD 4, 5 solver. So keep in initial phase you keep rest all this as a default values, and then you just click onto the simulation. It will start simulating. It will take up all c, k, m values and it will simulate, and it will tell you in the scope you can observe the variation of input signal and output signal. When you double click onto this block, you will get the results. So this is click onto this, you just look into the so input is I think 0. I can now set the value to the final value to the somewhere 100. So this gives an results of simulation of MATLAB model. When you click onto this, it will show you the results onto this scope block. You can maximize it. If you want to increase the value of this to an higher value or somewhere 5000 as a step value for this, so it will automatically shift to the higher side and it will show you the results. So this is the way you can do a modeling for this. Thank you.